Explicit teaching is an important element that teachers must be familiar with. Within this large concept, though, teachers can find strategies that can guide students into an understanding. Explicit teaching refers to an instructional practice that carefully constructs interaction between students and their teachers. This can be explained in 2 words: direct instruction. Teachers need to make sure that the instructions provided are clear and very direct. Teachers need to constantly review the information that was previously taught. They also cannot rely only on words, but the new concepts must be modeled and demonstrated for students. It's important to have the students be active in their own learning. It is also important that teachers guide their students through the mathematical problems. This way, students are more prepared when they move forward towards doing their work independently. Within guided practice, it is important that when students are struggling, that the teacher is not beyond reteaching the materials. Independent practice is an important element in any educational setting. This is where students have moved to doing the work on their own. It is also vital that there is a consistent amount of assessments that are happening to make sure that there is a progression among the students' learning. There are 4 instructional domains that teaching falls into: conceptual understanding, declarative knowledge, procedural knowledge, and problem solving. So let's talk about this just very quick, and in general we'll go into more depth later. Conceptual understanding, this is the basic goal. Having this understanding promotes a further confidence in future math classes. It can be the starting off point for students to begin thinking of problems in the real world and how to solve those problems. Then declarative knowledge. This is the knowledge that the students memorize. This is that knowledge that students can automatically recite back without having to put too much thought into it. Procedural knowledge. This is the area of developing those strategies that can help students complete a problem. These strategies are commonly taught to the students. And then finally, problem solving. This is the skill that students will put into practice in the real world. So let's look at conceptual understanding. What are a couple of strategies that can be used? They are advanced modeling, or advanced organizers, and modeling. So let's look at advanced organizers. Advanced organizers has a goal of promoting a student's success. It sets the stage for the lesson. They can include 3 primary components: review of prerequisite knowledge for the upcoming lesson, stating of the objective for the lesson, and an explanation as to why the learning of the new concept is important. And then we'll move on to modeling. Modeling includes the 3 M's, which we'll actually discuss more when we talk more about demonstration. But it is important that there is a demonstration of what will be involved in solving specific problems for each kind of problem out there that the students are going to be required to answer. Declarative knowledge. Strategies are again vital in this form of knowledge development. Here, teachers can use the 3-step labeling procedure and the 1-minute timings. The 3-step labeling procedure has 3 steps that must be used. The steps are modeling, alternating test pattern, and delayed testing. Modeling is pointing at an object and naming it. Then the student will repeat the naming back and forth until they learn it and they can catch it. Alternating testing patterns are important. The teacher shares a new example of the problem that the class is solving, and then the teacher brings up previous examples that the class has looked at. Finally, the last step is delayed test. This means that after looking at numerous examples and moving on in the lesson, then the teacher refers back and has the students refer back to previous examples that they used. Then there's 1 minute timing.
There's a simple way to access, 1 minute timing is a simple way to access the student's understanding and to see if they are actually memorizing this. The point is that the student has 1 minute to answer as many math problems that they can. Not only is it answering the problems, but it is specifically about how many problems students can answer correctly. Procedural knowledge. These strategies are about how to actually solve mathematical problems. So we're looking at the SAW strategy and the DRAW strategy. SAW is obviously one of these strategies. SAW means set up the problem to solve, attack the problem, and then wrap it up. These are the general steps that one will take to use this strategy, but the important part to remember is that under these general steps taken, they need to be broken down into smaller steps per the problem that is being solved. It is about setting up the problem and figuring out what needs to happen. Then it is creating a plan of attack and finally answering the problem. DRAW is another strategy that can be used. It stands for discover the sign, read the problem, answer or draw and check, and write the answer.
Like the SAW strategy, these steps are vague and there needs to be steps added depending on the problem. The important element of this strategy is that it gives the students the opportunity to draw in a way to figure out a problem. So problem solving skills. We're going to look at two strategies, fast draw and signs. Fast draw is a strategy that is actually broken down for students to easily follow. It stands for find what you are solving for, ask what are the parts of the problem, set up the numbers, tie down the sign, discover the sign, read the problem, answer or draw and check, and write the answer. Again, this strategy also has the option of drawing out the problem to help in solving the problem. This strategy gives students a way to break down the problem in steps that can make it easier to accomplish the goal of the problem with success. The sign strategy is another strategy that can be used. It stands for survey the question, or in other words, look over the question. Identify keywords and labels, which is your I. Graphically draw the problem. Note the type of operation or operations that are needed to solve the problem, and solve and check the problem. Honestly, I wish I had an algebra teacher who would have used any of these strategies when I was in school. Maybe I actually would have gotten the A instead of a C when I was in school all those years ago. So I want to circle back to explicit teaching, and no pun intended. This is a cycle that happens. So it starts with curriculum-based assessment, then moves to planning, and then to advanced organizers. Next is demonstration, then guided practice, independent practice, and finally maintaining and remembering the information that was taught. Starting with curriculum-based assessment. This happens prior to any instruction and can create a baseline for the teacher to start with. Planning is the next step. This is where the data from the curriculum-based assessment comes into play. This is where teachers can plan the best plan of attack for their class and for each individual student. Advanced organizers are a tool to help pique the student's interest in the topic. This can be done in a multitude of ways, and there is not one specific way to do this, so you can have fun with this. Next is demonstration. This is where those 3 M's come to play that I mentioned earlier. The 3 M's are model, thinking, and action. This is showing the students the thought process needed to solve a problem. Next is maximizing the student's engagement. This engagement happens through verbal communication. This can be through prompting the student and asking questions. The last M is monitoring the student's understanding of the topic. This again is through those verbal communications, or the looks on the students' faces to see if the students are actually understanding the topic. Now, guided practice is an important element of a lesson. Students have a chance to actually practice what the lesson is about, but here is where the teacher will prompt and guide the students through the steps to solve the problem, hence the guided in the word before practice. Then they have independent practice. This is when students no longer need the teacher to guide them through the steps. When this happens will vary for each student. And then finally, maintenance. This is the last element. This is the continual understanding of the topics that have been studied previously. This is when that assessment happens to see if students are remembering the information. And that's an important element because if they don't remember the information from a previous lesson or a previous unit, then you can't build up on the next on those skills for the next lesson or the next unit. Explicit teaching has a multitude of facets that must be navigated. Each facet is meant to build upon a student's knowledge and provide the students with the skills to be successful in mathematics. And these are my resources that I use. Please feel free to go and look at them. They are amazing.